When we talk about housing, many people look outward. New construction, densification, new land. But most cities are already built. Streets are fixed. Buildings remain. Yet one of the largest unused housing potentials lies directly above our heads. In the attic. In Europe, pitched roofs are the standard, historically, climatically and structurally. Around 70 to 85% of all residential buildings here have a pitched roof. In the United States, the share is even higher, particularly in single-family housing, at around 90%. And even in Asia, pitched roofs remain widespread despite high urban density. Depending on the region, up to 75% of residential construction features pitched roofs. The key difference lies primarily between urban and rural areas. In dense urban environments, flat roofs become more common, while in rural and suburban residential construction, pitched roofs clearly dominate worldwide. The pitched roof is therefore not a special case. It is the global norm in residential construction. Yet countless attics remain unused or underused, as storage space, as technical space, or simply empty. In this episode, we take a closer look at how an attic with a pitched roof, more precisely a gable roof, can be optimized in a meaningful and economically efficient way. Not as a showcase renovation, but as a functional, realistic solution. We are looking at a residential building with a gable roof and a roof pitch of 42 degrees. The floor plan is rectangular, measuring 8 by 12 meters. The attic is currently empty and is intended to be used as efficiently as possible. With gable roofs, usability is limited by the roof slopes. The dashed lines illustrate these constraints. Within the two inner lines, the space is fully usable. These are the 2-meter lines, indicating the height up to which an adult can stand fully upright. The 2 outer lines mark the 1-meter zone. Outside these lines, meaningful use is practically impossible. The area is shown in red. In this case, 26 square meters are lost. The areas between the 1 and 2 meter lines, totaling another 26 square meters, can be used in a limited way. They are suitable for furniture, but not for circulation areas. In this example, 36 square meters of fully usable space remains. One way to increase usable space is through dormers. Shown here, a gable dormer. With the dormer, the 1 and 2 meter lines shift. As a result, the area within the dormer becomes fully usable. The non-usable area is reduced from 26 to 23.5 square meters. The partially usable area changes accordingly. The fully usable area increases from 36 to 40 square meters. In practice, however, dormers are often limited or not permitted due to structural or legal constraints. In such cases, roof windows are used to provide daylight. However, this does not change the amount of usable floor area. To avoid poorly usable peripheral zones, knee walls are often installed. When placed at the 2-meter line, however, the room quickly feels cramped. Nevertheless, the remaining space then amounts to 35 square meters and is fully usable. An alternative is a knee wall positioned at the 1 meter line. This increases the usable floor area to 61 square meters. The challenge is to combine efficient use of space with a convincing sense of room. Instead of traditional knee walls, built-in wardrobe systems can occupy these zones. Storage is created where full standing height is lacking. Cleaning effort in hard-to-reach areas is reduced. And the overall spatial impression is improved. Although the usable area remains formally limited, the room feels significantly more generous due to the depth of the cabinetry. Nevertheless, a substantial amount of space remains unused behind the cabinets. An area ideally suited for bulky and rarely used items such as skis or winter equipment. By integrating a door into the built-in wardrobe, this area becomes selectively accessible. However, access requires a crouched posture similar to a crawl space. For children, such areas are often attractive as secret hideouts, so cleaning efforts may increase. Another option is the integration of temporary furniture that remains visually concealed in everyday use. Here, a pull-out bed is hidden. The room becomes a guest bedroom. Depending on the roof pitch and knee wall height, bed height is limited. In this example, without a knee wall, with a 42-degree roof pitch and the cabinet positioned at the 2 meter line, a maximum bed height of 30 centimeters is feasible. By adjusting the depth of the cabinetry, this limitation can be compensated. At the same time, additional shelf space is created. When the bed is extended, this surface functions as a bedside table. Optionally, the adjacent cabinets can be equipped accordingly, so that the conversion and use require minimal effort. Targeted spatial separation can further enhance quality of the space. The anteroom is fully fitted with cabinets to maximize storage capacity. At the same time, this visually enlarges the room beyond. In the sleeping area, the wardrobe is installed on only one side. Seating furniture loosens up the partially usable zone. Where possible, an additional dormer can further improve spatial quality. What we have seen here is not a special case. A typical roof, a typical house in a typical town. And precisely for that reason, this is where one of the largest and most often overlooked housing potentials lies.